We're going to be looking at the exponential distribution to finish this short unit. Also, I'm going to be using a calculator. I'm going to be using Desmos.com. All right, that calculator I want you guys to get familiarized with. I'm going to use Desmos.com. So let's see. Exponential distribution. What's an exponential distribution? Well, this is often concerned with the amount of time until something specific happens. Let's see, for example, what's the time from now until an earthquake occurs? What's the time from here until like a long distance call ends? Or the time from here until your guys' final, right? So it does measure amount of time until something specific happens. Let X be the amount of time in minutes a postal clerk spends with his or her customer. The time is known to have an exponential distribution with the average amount of time equal to 4 minutes. Okay, that's important. Let me highlight this. The average amount of time equal to 4 minutes. So that means if I go to the post office, they're going to spend about 4 minutes. Could be more, it could be less. Find a DK parameter. We're going to call this an M, which is a very important number. We're going to be using this M a lot. Now I'm going to say M. We're going to figure out our parameter, our DK parameter. M is going to be 1 divided by our mu, 1 divided by our average. Remember how I said the average amount of times equal to 4 minutes? So in this case, I'm looking at 1 divided by 4. Now 1 divided by 4 is equal to 0.25. When I graph this, I actually expect it to look like an exponential decay. Now, you guys learned back in algebra 2, remember an exponential increase looked something like this. It was going up. It looked like a curve going up. I expect my decay, exponential decay, to be going down. That's how I expect this graph to look like. Now, the standard deviation is the same as the mean, which we're going to say our mean is equal to standard deviation. And the distribution notation is going to be expressed as x is an exponential, and then our m, which in our case is going to be x represents an exponential distribution of 0.25 because we found out that our m was 0.25. Now the probability density function is noticed as f of x is equal to m times e to the negative mx. Now e is a number. I even wrote it over here. The number e, it's after Euler. It's about 2.7. It's a never-ending number, kind of like pi was a never-ending number. Now, the number e, you guys can find it on your calculator, is about 2.7. Okay, so now the curve here that we can see here, this is my exponential decay. This is kind of like what I was expecting. Remember, I told you guys I was going to be using decimals, but let me show you guys in decimals how to get this graph. So let me change screens here. I'm just going to go to decimals.com. I have here, and I'm going to go graphing calculator. So it opens this thing up. Okay. Now, my curve, I want to do 0.25. So let me graph this. I'm going to go y is equal to 0.25 times e. Okay, so I don't want to type, so let me bring this up. Times e. I don't see the letter e, but I can always type it on my keyboard. E. And I need to go to an exponent. So I'm going to use this key here, which is a to the b. So there, it shows me the exponent. And I'm going to write negative 0.25 times, oops, no, I don't want to get out of the exponents. So in that case, let me use parentheses times x. Now that gives me this graph. If I look into the graph here, notice I crossed at 0.25. So it gives me this graph. Let me come back to the graph that I had given you. It's about this graph. So that's where I got this graph. And remember, my mean is 4. Now here I can do some things. Now I had a typo here on our formula here. No, no, my bad. I do have this supposed to be, my probability is going to be 1 minus e to the negative mx. Okay, that's how that thing's supposed to look like. Now let's find the probability that a clerk spends 4 to 5 minutes with a randomly selected customer. Now, one thing I want to talk about here, about my probability function here. I can find out what's the probability that this clerk, remember the mean was 4, what's the probability that this clerk will spend 5 minutes, 2 minutes, 7 minutes, any amount of minutes that I want to figure out. The way I will figure this out, let's say I want to figure out what's the probability that this clerk will spend 5 minutes on the next customer. What I'm going to do, so for 5 minutes, I'm going to say, well, f of 5 is going to be m. And remember, our m is, in our case, 0.25 times e to the negative m times 5. This is something I can type in easily. Let me type this out, actually. Let's go to decimals. Let me take this graph out. So remember, I wanted to know what's 0.25 times e to the negative 0.25 times 5. There. So the probability that this person will spend 5 minutes, it's 0.07. There's a probability that the clerk will spend 5 minutes on the next customer. Now, what's the chance? What's the probability that the clerk is going to spend with the next customer 5 minutes or less? That's the formula that I just gave you guys. Let me come back to the formula that I mentioned about here. So here, for example, if I want to know what's the probability that the clerk is going to spend 5 minutes or less, I'm basically asking what's the probability that x is less than 5. So not exactly 5 minutes. We just figure out what was the probability of 5 minutes. Now I want to know what's the probability of 5 minutes or less. So then we just say 1 minus e to the negative 0.25 times 5. All right, let me figure that out. Let's go to decimals here. And let me go 1 minus e to the negative 0.25 times 5. Okay, so the probability that the clerk is going to spend 5 or less is 0.71. Make sure you look at the difference of these two. The probability that the clerk is going to spend 5 minutes with the next customer is 0.07. The probability that the clerk is going to spend 5 minutes or less is 0.71. Now, let me come back to our notes here. Find the probability that a clerk spends 4 to 5 minutes with a randomly selected customer. Oh, okay. Now, what's the probability that the clerk is going to spend 4 to 5 minutes with the next customer? I know how to do probability that the clerk is going to spend less than 5 minutes. Remember, for that one, I go 1 minus e to the negative 0.25 times 5. That's the probability that he will spend 5 or less. I can also find out what's the probability that the clerk will spend 4 minutes or less. And now when I go 1 minus e to the negative 0.25 times 4. Okay, well, let me figure it out. Let me actually do these. I'm gonna use my calculator. I'm not gonna show you guys on the screen, but we can use decimals for this. For the first one, 5 minutes or less, let me write this as 0.713495. I don't like to round my work. I like to round my answered. But unfortunately, I cannot write all the numbers here, so I'm just going to leave it at this, just 6 decimal numbers. Now, what's the probability that the clerk will spend 4 or less? I type this in on my calculator. Like I said, we can use decimals, and I get 0.632121. Okay, so I know what's the probability that the clerk will spend 5 or less. What's the probability that clerk will spend 4 or less? For me to find out what's the probability that the clerk's going to spend 4 to 5 minutes, we'll find the difference between those two. Just subtract them, and I'm going to say 0.08. I rounded my answer to 2 decimal places. When I was doing my work, I was doing 6 decimal places. My answer, I do round it to 2 decimal places. Oh, so I can figure out what's the probability that the clerk can spend between 5 and 7 minutes, right? Find the probability what's 5 or less, find the probability of 7 or less, then subtract them, and that's going to be the probability that the clerk spends between 5 and 7 minutes. I can ask you any range, but at the same time, I can ask you for a percentile. Find the 15th percentile. So the number that is equal to 50%, right? So 50% of the customers are less than this number. Now, I'm not going to use X. I'm going to use actually K. So for this, what I'm asking is, what's the probability that any given number is less than K? But I want this probability to be 0.50 because it's 50th percentile. If I ask you for the 75th percentile, it will be 0.75. Okay. Now, I know formula for X is less than K, right? The probability that it's going to be less than K minutes. So I'm going to go 1 minus E to the negative 0.25 times K. And I know this is equal to 0.5. Right, 0.50, I'm just going to write as 0.5. Okay, my next step, let me subtract the 1. I'm going to cancel this 1 here by subtracting it on both sides, because technically I subtracted a 1. So I have that negative e to the negative 0.25 times k is equal to negative 0.5. Right, 0.5 minus 1 gave me negative 0.5. Interesting though, Look, I have two negative signs. If I multiply by -1, wouldn't the negative signs disappear? Okay, so let me do that. So I have e to the negative 0.25k is equal to 0.5. Now, how can I bring the exponent? I wish there was a way for me to bring the exponent down. So I'm looking at this exponent. It would be nice if I could bring it down and get rid of e. You should remember, back in Algebra 2, back in advanced algebra, you learn how to bring exponents down. Whenever we talk about log or natural log, every time we're dealing with e, we're going to deal with natural log. So let me do ln of each. So ln is basically natural log. We learn that the exponent does come down. And another thing we learn is that ln of e is 1. So in reality, I have negative 0.25k times ln of e, so that's a times, it's equal to ln of 0.5. But we learned that ln of e, natural log of e, is 1. For space purpose, let me use the right side of our screen. So I have that negative 0.25k is equal to natural log of 0.5. In fact, let me use this type of L. ln 0.5. I remember algebra. To get that k by itself, shouldn't I divide both sides by negative 0.25? So let's say my k is natural log of 0.5 divided by a negative 0.25. Use your calculator necessary. Well, actually, you'll have to use a calculator. Use decimals if you need to. Like, Mr. Leonzo, can you show me how to do this in decimals? Okay, let's bring decimals out. So I'm gonna use this new thing here. So I'm gonna go ln. So natural log. I'm gonna go here on functions. Do I have natural log here? There, you see ln. So I went ln of 0.5. Let me close my parentheses. Divided by, right? That's just we use for division. Now divided by, you can use a divided by. And I remember at the bottom was a negative 0.25. Press equal. Okay, there's my answer. You guys see? Natural log of 0.5 divided by negative 0.25. It says 2.7725. Let me come back to our work here. So I'm going to say k is equal to, I'm going to round it to 2 decimal places. So let me call this 2.77. So 50% of our customers are with the clerk for 2.77 minutes or less. I could ask you for the 80th percentile. I could ask you for the 10th percentile. If you have any questions, you know where to find me. You can just email me and I can help you guys out.